Hello students, welcome back to Physics with Safdar. Now you are watching FBISE Past Paper Solution series. Today we are going to solve numerical problem of paper 2019 for class 9. So let's start the solutions. This is question number 4 from section B, paper 2019. The question is, a body of mass 5 kg is moving with a velocity of 10 meter per second. Find the force required to stop it in 2 seconds. Look at this diagram. This diagram would help you to understand the concept. What is the question we have? This is the object of mass 5 kg. Initially it is moving with velocity 10 meter per second. Because of application of force, it stops, means its final velocity goes to 0 and time taken 2 seconds. Then you need to calculate that stopping force. First write the information given and required. You know the mass of the object is 5 kg. Initial velocity is 10 meter per second. Final velocity is 0. Time taken 2 seconds. And finally we need to calculate force. To the calculation of force you have an option. You can calculate force by using Newton's second law of motion, mass times acceleration, and second you can calculate force by using the rate of change of momentum idea. You can use any one equation. I'm going to solve force by using rate of change of momentum. So this is the equation you need to calculate the force. F is equals to change in momentum divided by time taken. The change in momentum you can write final momentum minus initial momentum. Pf is equals to, momentum is the product of mass and velocity, so you can write here the mass of the object and its final velocity. The mass of the object is 5 kg and the final velocity is 0. So final momentum we get 0. Initial momentum, that is Pi, again mass into initial velocity. The mass is 5 and the initial velocity was 10. After the simplification we get 50 with unit kilogram meter per second. F is equals to change in momentum divided by time taken. The change in momentum means final minus initial momentum, so you can write 0 minus 50 over time taken, that is 2 seconds. After the simplification we get 25 Newton with negative sign. The negative sign shows that it's a decelerating force. Question number 10 from section B, paper 2019. A girl carries a 10 kg bag upstairs to a height of 18 steps, each 20 cm high. Calculate the amount of work she has done by carrying the bag, and you can take G is equal to 10 meter per second squared. Look at this diagram. You can see clearly a girl with a bag of mass 10 kg. She carried this bag up to a height of 18 steps, each of 20 centimeter high. So this is the height of one step, that is 20 centimeter. So we need to calculate work done by the girl. First write the information given and required. In this case we have mass of the bag, that is 10 kilogram. You can calculate weight of the bag by using this equation, that is m times g. So we get mass is 10 and we have to take g is 10. So finally we get 100 Newton. Then we have number of steps. So number of steps we have 18. And height of each step is 20 centimeter. And we need to calculate work done. In step 1, write the equation for work done. Work done is equals to force time displacement, or distance covered in the direction of force. In this case, the force is equals to weight of the object, so you can write F is equals to weight of the object, weight of box. The distance you can calculate as number of steps time the height of each step. After the multiplication, we get 360 centimeter. Now convert centimeter into meter. 360 divided by 100, then we get 3.6. Now you can calculate the work done easily. Work done is equals to F times D. The force is equals to 100 Newton and D is 3.6. Multiply the numbers, then we get 360 with unit joule. That is the final answer. Question number 11, section B, paper 2019. The question is, the weight of a metal spoon in air is 0.48 Newton. Its weight in water is 0.42 Newton. Find its density. Look at this diagram. There is a spoon in air. The weight is measured, that is W1, 0.48 Newton. Then a spoon in water, again measure its weight. It's recorded W2, that is 0.42 Newton. The weight of the stone decreases. The weight of the spoon decreases because upthrust of the liquid. So we need to calculate the density of a spoon. Write the information given and required. The weight of the spoon is given, W1, 0.48 Newton. The weight of the spoon in water is given, that is 0.42. The density of water, we need to remember this. The density of water is 1000 kilogram per cubic meter. It's not given in the question, but you need to remember here, and you need to calculate the density of a spoon. This is the question. By using the Archimedes principle, the density of a spoon we can calculate by using W1 over W1 minus W2 times density of water. Now you can substitute all the numbers. W1 is 0.48 over 0.48 minus W2, that is 0.42, times density of water, it is 1000, and finally we get the density of a spoon, 8000 kilogram per cubic meter, and that is the final answer. This is section C, paper 2019, question number 3, part C. The question is, a body has weight 20 Newton. How much force is required to move it vertically upwards with an acceleration of 2 meters per second squared? First write the information given and required. The weight of the object is 20 Newton. W is equals to 20 Newton. Upward acceleration is 2 meters per second squared. And you need to calculate that force. One thing, look at the diagram. This is the object we have and we want to lift this object. The weight of the object is 20 Newton and this is the force we need. In this case, if you want to lift the object with certain acceleration, you need a force. So you can write the force is equals to weight plus external force. The weight is equals to mg and external force, you know well, m times a. You can write by taking m as a common factor, g plus a. This is equation 1. To calculate the force, we need three things. You need mass, you need gravitational acceleration, and acceleration of the object. We don't know the mass. G is 10, A is 2 meters per second square. So first we need to calculate the mass by using the equation of weight. W is given. W is equals to 20 Newton. You can write W is equals to m times G. Then make m as a subject. M times G, you know well, 10 and 20. And finally, m is equals to 20 over 10. It gives 2 kilogram. Now we can use the equation number 1. After the simplification, we get 10 plus 2 times 2, that is 24 Newton, and that is the final answer. Section C, question number 4 and part C. A motorboat moves at a steady speed of 4 meters per second. Water resistance acting on it 4000 Newton. Calculate the power of its engine. Look at this diagram. A boat is moving with the steady speed 4 meters per second and the water resisting acting on the boat 4000 Newton against the direction of motion. This is the direction of motion and this is the direction of force acting. We need to calculate the power of the engine. First, write information given and required. So we have the study speed of the board, that is 4 meter per second. The resistance of water 4000 Newton. And we need to calculate power of the engine. The power of the engine you can calculate by using this equation. Power is equals to force times speed. In this equation we have both things, we have force and speed, so you can find the power easily. The force is 4000, speed is 4. Multiply the numbers 4000 with 4, then we get 16,000. The unit of power, you know well, it's watt. You can change your answer in watt to kilowatt. For that you divide the number 16000 with 1000, then we get the answer in kW, kilowatt. We get finally, after division with 1000, 16 kilowatt, and that is the final answer. Section C, question number 5, part B. The question is, a container has 2.5 liters of water at 20 degrees Celsius. How much heat is required to boil the water? Look at this diagram. This is container containing water 2.5 liter and initial temperature is 20 degrees Celsius. Then start heating till boil. The water gets temperature 100 degrees Celsius. So we need to calculate that heat required. First, write the information given and required. We have volume of water, that is 2.5 liter. Then mass of water. 1 liter has 1 kilogram of mass. So you can write 2.5 liter of water, 2.5 kilogram. Specific heat capacity of water. It is not given in the question, but you need to remember this. 4200 joules per kilogram Kelvin inverse. And you need to calculate the heat required, that is Q. The heat required to raise the temperature of water from 20 to 100 degrees Celsius, you can write Q is equals to M times C delta T. Here M is the mass of the water, it is 2.5, times the specific heat capacity, that is 4200, and change in temperature 100 minus 20. After the simplification we get 840,000 joules. Now you can change your answer joules to kilojoules as the number 840,000 divided by 1000. (840 kilojoules), and that is the final answer.